Most people try to build apps with tools like Flutterflow and AI assistants by searching for one perfect method. But that's where they go wrong. The real breakthrough comes when you combine three powerful approaches that each solve a different piece of the puzzle. Once you understand how they work together, everything from structure to scalability starts to click. At the overall level, this combined approach works in layers. At the product and process level, Agile should guide your workflow through short iterations, small incremental changes, and continuous feedback. At the architectural level, clean architecture combined with DDD provides a clear separation of concerns and a strong focus on the domain. At the implementation level, you should rely on algorithmic thinking and computer science principles to design efficient data structures, ensure performance, and maintain correctness. This layered approach integrates well with low-code tools and AI coding assistants because it provides them with a clear structure and defined responsibilities, preventing the generation of disorganized or super spicy code. I've created or documented a planned or programmed and traditional programmed approach for creating the static web stack application for HTML, PHP, JavaScript, and a MySQL database running on XAMPP. The idea here was to take the data I had from the create, update, delete, add listing feature and migrate it into MySQL database. Demonstrates how the same domain logic can live in different stacks. I created static HTML JavaScript pages as the front end, PHP scripts to handle server-side logic and connect to MySQL schema that mirrors the listing data so I could perform create, update, delete operations from the environment as well. As from the software engineering standpoint, I have managed to create tables related to the structure and implement new data techniques that will enhance the infrastructure of the website static application. Due to the dynamic use of JavaScript, the JavaScript could navigate different data conversions between the database MySQL and the static website, and it was between the website from HTML and the MySQL database as a middleware where it manages the interchanging request from the website and database application. As I was creating these applications inside the website, let's start with the mobile app. I built an ad listing app in Flutter using Supabase as the backend API and database. My goal here was to practice architecture and modern software engineering techniques while still shipping something practical. On the Flutter side, I focused on clear separation between UI business logic and data layers, using asynchronous calls and error handling around the Supabase API, making the UI reactive so listings update immediately when data changes. I used the module context protocol and Claude's code tool to help generate and refine parts of the code. This let me move faster, but I still refactored everything to keep the code base readable and maintainable. On the back end, Supabase handled authentication for users and add listings. A Postgres database where each listing has fields like title, description, and any metadata. I need. Simple create, update, delete operations exposed it as a RESTful API that the app could call. So this first part gave me a solid cloud-backed mobile application for creating and managing listings that were operating inside the mobile app. So with good software engineering practices, I was able to digest the API calls that I was trying to make when I was calling the DVLA data that I was trying to use to fetch different licensing car plates from the car vehicle API data website. As I've run out of payment API payment subscriptions, most of the data request has been filled. In order for me to active the request, I had to active my subscription in order to get live driving plate data. So I had the Flask app. I added the most interesting part, machine learning model for nutrition and body. I built three classifiers regression modules focused on predicting the weight and body composition based on current historical data recommending the type of nutritional diet, gaining, losing, and maintaining weight, suggesting supplements and daily calories to keep my body weight healthy. To keep these modules, I integrated data from Nutritionix API and other food-related APIs. This gave me structured nutritional data like calories, micronutrients, and sometimes micronutrients for different foods. The pipeline looks like this: collect food and nutrition data from the APIs, clean pre-process the data, handling missing values, normalizing features, and encoding categories. Inside Flask, I wrapped each module in a simple service. Service inside a simple service. Receive user input from forms or API calls. We run appropriate module. Return clear recommendation back to the user interface. This turns raw machine learning into something actually usable. A personal assistant that guides you on diet supplement choices and calorie targets. To recap, in this video, I showed you how I combined several software engineering techniques into one end-to-end project. A Flutter mobile app with Supabase for adding and managing listings. A Flask web app styled with Tailwind, CSS and lovable style layouts. 3 machine learning models for predicting weight, diet type, and supplement and calorie recommendations powered by Nutritionix and food APIs, and a static HTML, PHP, and JavaScript site with a MySQL database to demonstrate data migration and create update delete operations in a classic stack. If you want a deeper breakdown of any part, Flutter, Supabase, Flask, Tailwinds, or the machine learning models, let me know in the comments. And I can create dedicated videos for each. Thanks for watching, and I'll see you in the next one.